それでは最初の講師、Curtis さんからホライゾンヨーロッパプロジェクトについての経験をお話しいただきます。Curtis さん、お願いします。
Ladies and gentlemen, I'm Curtis Kuan from Industrial Technology Research Institute. Today, it is my pleasure to be here to share my experiences with you. In this presentation, I want to describe how we joined the Horizon Europe project, HARTU, related to flexible manufacturing with advanced AI-enabled robotics. This is a Horizon Europe project. We call it HARTU. Hope you will get something during this presentation. Thank you. First, here is the outline of today's presentation. First, a brief overview of ITRI robotics is introduced. Then, how we joined the HARTU project, including the origin, the progress to HARTU, and what exactly HARTU is. Finally, a conclusion is provided. As we know, ITRI was founded in 1973. It's an independent nonprofit innovation institution in Taiwan. And our scope is developing technology for commercializations and nurturing opening innovation with academia, industry, and global partners. That is why I am here to introduce our global collaborations, especially with the European partners. And the other scope is incubating and spawning startups for emerging industries. And as we know, the most famous spin-off companies are TSMC and the UMC in semiconductor areas. And ITRI has several offices around Taiwan and the global branches in Tokyo, Japan, San Jose, Silicon Valley in the United States, and Berlin for the European business. And here is our basic information about ITRI. We have Tainan campus and the headquarters in Hsinchu and the Taichung campus. And we got many staff with PhD degrees, master degrees, and we have total patents around 32,000 and more. And this slide will introduce our robotics achievement in the past years. And for the future, we have robotic development in ITRI. We have core technology related to controllers that we call it I Can Think. The vision system for robotic system that we call I Can See. And the several applications, use cases in the practical industrial area. We call it I Can Walk. And the mobility, I Can Move. And for the I Can Think, we especially developed the robotic controller and the navigation algorithm and the simulators with EasySync and AsaSync. And the vision system is for the robotic system. We call it FOV vision, especially for object recognition and navigation. And I Can Walk, we have implemented several industrial applications such as in aerospace manufacturing, drilling, or painting for the high-speed railway, and the grinding and the polish application for the semiconductor instrument, and the robotic weaving system for the composite material handling. And I Can Move, we have developed the dispatching system for multi-AMRs, and we have a fleet management software for AMR system. And this system right now is introduced to a semiconductor plant. Furthermore, we also have the medical robot is our focus as well, such as robotic bronchoscopy with diameter less than 3.5 millimeters. And here is our brief overview of our robotics achievement. Here, the next page, we want to say how we met Horizon Europe HARTU. And I want to introduce the origin of the origin. From 2002 and 2003, we have joined the European project, we call it Muffins. This project is related to the multimedia processing in the MPEG 21 environment. Here we can say ITRI is one of the partners, and the other partners are Imperial College in the United Kingdom and the IMEC for the Belgium and the other partners from all over the European countries. And the other project from 2003 to 2005, and we got another partner from Switzerland. From this project before, based on our research capability in the past, almost 20 years ago, we joined these two projects. From these experiences with European partners such as Fraunhofer, Imperial College, IMEC, Vodafone, we have learned several lessons. The first one is the basic core concept idea is very critical. Use cases and the user scenario first. Then we, based on this user scenario and the requirement, we can implement the technology development. And diversity in the project partners. As we show, there are several various partners from the industries, including the universities, industrial company, and academia research institution. So this diversity will bring the project different thinking logic and excellent sparkles during debate argument. And finally, we will get the consensus and the compromise from each other, and we will do our job or do our task, complete our task, what we have assigned, that we call it due diligence. And in these projects, they encourage participation in standardization activities and promote the achievement from the project to standardization organizations. So from these experiences, project achievement will be more applicable to the real and the practical use case in the industrial applications. That's why we have interested in joining the Horizon Europe project. So here is the slide showing our way to HARTU. In 2017, we from the EU-Taiwan Industrial Policy Dialogue, which have decided we need to discuss on the AI robotics. EU and Taiwan agreed to focus on the development of AI plus robotics and start the preparation of robotics working group. And in 2019, we have established the EU-Taiwan Robotics Working Group. In this working group, we discuss the regulations, policies, and the joint research topics, especially on AI, data, and robotics. And this group is established based on the consensus of European Commission Director Generals. For example, DG Grow, DG RTD, and the DG Connect, especially for the ICT technologies. Through 2020 to 2022, both sides of EU and Taiwan discussed the joint research topics, including the digital twin, human-robot collaborations, and the AI robotics. And based on our consensus from both sides, in 2022, ITRI cooperated with the German AI Research Center, DFKI, and the Spain Research Institute, Technical, and the Philips Consumer Electronics, and the Turkey Automobile Company, forming a research consortium. We call it HARTU. And this project got approval by European Commission, and the project kicked off in this year, January. And in this project, there is a company from Taiwan, Infra, also joined this research consortium. So, what exactly HARTU is? HARTU means is the abbreviation from handling with AI enhanced robotics technology for flexible manufacturing. And as we described in the previous slide, there are several partners from all over the Europe countries and 2 partners including ITRI and Infra from Taiwan. So all partners are listed as this figure shows. And what HARTU is, we want to focus 5 use cases. The first one is the fixtures assembly, especially for the hand tool manufacturing. And here, this use case will be implemented by ITRI and the Infra, the Taiwan partners. And the second, the use case is the assembly for the consumer electronics. And this use case will be implemented by the Philips and the Technical. And this use case is from the Netherlands. And the logistics use case and the car assembly transport, this use case is implemented from Technical and the Tofas, the Turkey automobile manufacturer. And especially for the packaging use case, is about the food handling. It's implemented by the Italian partners, Poliva. And in this use case, we want to focus on how to grasp a workpiece, such as how to grasp the workpiece in the right position and the right orientation. So here we will handle various workpieces such as hand tool, electronic components, foods and vegetables and others. And from grasping, we need to assemble all the components into one product. So we need to handle the contact force, assembly procedure, and accuracy, and the compliance between the workpiece and the adaptation to various workpieces with different size and weight. And finally, we have to put or place the assembled product into the right place. So we need to handle the position and how to package all the workpiece. So here is our scope for the HARTU project. And finally, here is a brief conclusion. From the slide before, HARTU is a real international research project with 6 countries without mother tongue as English. So participation in this project, we will learn how to cooperate with various countries from Germany, Spain, Italy, Netherlands, Turkey, and Taiwan. We will, as we said before, we have to achieve the consensus and the compliance to each other and do the assignment work with the due diligence. And here is the reference for the Horizon Europe Cooperation Framework. The European Commission has assigned 95 billion budget for the research and the innovation activities. And one more slide for the Horizon Europe. We have in this Horizon Europe, there will 49 European partnerships, including several clusters. For example, health, digital, industry and space, climate, energy and mobility, food, bioeconomy and agriculture. And for us, we will pay more attention on the AI and the robotics. So here is for your reference. If you are interested in participating in EU project, we can cooperate. Thank you.
Curtis さん、貴重な経験談をいただきありがとうございます。さて、今から Q&A 時間に入りますが、ご質問のある方はチャットにてもしくは挙手ボタンを押していただき、直接ご質問ください。はい、それではアンケートより頂戴したご質問から回答してまいります。Question 1. How AI can impact advanced manufacturing?
Yes, thank you everyone. So thank you everyone to join this seminar. So here I'm Curtis. I will answer the first question. How AI can impact advanced manufacturing? As we know, intelligence we mean is the capability to predict then how long the period we can forecast and how correct we can predict will be the indices we say someone has wisdom or not. Accordingly, AI is similar to the capability to determine the appropriate action under current state and based on the past experiences. That means if more data can be collected for AI learning, the capability of learning algorithm can extract insight from big data, and probably the correct prediction could be made. Applying this kind of concept to manufacturing, AI can be applied to deal with uncertainties during the manufacturing processes. So this is how AI can impact advanced manufacturing. Thank you.
我々の定義するインテリジェントとは予測する能力のことです。そしてどれだけ長い時間予測できるか、どれだけ正しく予測できるのかが、その人が知恵を持っているかどうかの指標になります。したがって AI は現状と過去の経験から適切な行動を判断する能力に似ています。つまり AI は学習のために多くのデータを収集することができれば、学習アルゴリズムの能力はビッグデータから洞察を引き出すことができ、そしておそらく正しい予測を行うことができるでしょう。このようなコンセプトを製造業に応用することで AI は製造工程における不可欠性に対処することができます。それでは Question 2. What you have learned from cooperation with EU?
Yes, for the second question, based on our experiences for cooperating with the EU partners, we have learned due diligence, compromise, and consensus. As I said during the presentation before, so we can have arguments during the design phase, then consensus can be achieved, followed by due diligence. We keep our promises to fulfill our responsibilities. So here is we have learned from the cooperation with EU. Thank you.
Due diligence 妥協、コンセンサスですかね。あと、設計段階で議論を交わしてコンセンサスを得た上で、その後デューディスジェスを行って約束を守り、責任を果たすことです。皆さん、たくさんのご質問ありがとうございます。私どもも今後さらなる交流を希望いたします。